Hey guys, Mr. Martin with a quick video on differentials. So we've established in calculus firmly that dy over dx is equal to f prime of x or the derivative. Both dy and dx are called differentials. They are infinitely small differences between values. So dy, they're the tiny differences between the y values, and dx is the tiny differences between two x values that are very close to each other. If we multiply dx to the other side, we end up with this differential for y equals the derivative of x times the differential of x. So delta y is equal to the derivative evaluated at x times delta x. So given that y equals x cubed minus 4x squared plus 2x, we want to find the differential dy when x equals 2 and delta x equals 0.02. So dy over dx is 3x squared minus 8x plus 2. So we multiply dx to the other side, we get dy equals, we'll put in parentheses, 3x squared minus 8x plus 2 dx. We're given x equals 2 and delta x, or dx, is 0.02. So dy is equal to 3 times 2 squared minus 8 times 2 plus 2 times 0.02. So 412. So 12 minus 16 plus 2 times 0.02. So that's negative 4 plus 2. So negative 2 times 0.02 is negative 0.04. So dy equals negative 0.04 when x is 0.02. For example 2, we're looking, all right, so differentials can be used to determine a tolerance for a function. So we're trying to find the value of the differential dr that allows for a manufacturer to produce circles whose area differs from a circle of area 9 pi by no more than 0.05, 0.5. So if a circle has an area of 9 pi, we know that r must equal 3. Also, the area of a circle is pi r squared. So we know that dA is 0.5 because that's the difference from the area of the circle. So dA equals 0.5. We can say plus or minus. We'll talk about that in a moment. So when we calculate the derivative, the radius is the variable. So we get dA over dr equals 2 pi r. We multiply dr to the other side, so we get dA equals 2 pi r dr. So again, dA is 0.5, so we have 0.5 equals 2 pi, r is equal to 3 times dr. So this difference of 0.5 means we can be 0.5 above 9 pi or 0.5 below. So it says at this point we'll put plus or minus. So to solve for dr, we want to divide this entire thing by essentially 6 pi. So plus or minus 0.5 divided by 6 pi is equal to dr, and that would be 0.5 divided by in parentheses 6. Where's the pi key on the Casio? I have no idea. Oh, right here. Shift and pi. So 0. Let's say 27. So plus or minus 0.027. So that means that we could have we can add 0.027 to this. So R equals 3. So R plus or minus 0.027 is 3 plus or minus 0.027. So that's clearly, let's see, 3 minus 0.027 is 2.973 to 3.027. This is the range of values for the radius that give us an area close to 9 pi. So we can check that. 2.973 squared times pi is 27.76, and 9 pi is 28.76. So this is within the 0.5 that we were looking for. So last example is if x equals 2 and dx equals 0.05, find the differential dy for this implicit equation. So if we apply our derivative operator, we're going to assume x to be the independent variable. So we're going to have 1 plus dy over dx equals product rule. So derivative of x is 1 times y. So y plus derivative of y times x. So dy over dx times x. So we only know x equals 2, but somehow we need to find y. So 2 plus y equals 2y. That is the same as y equaling 2 because we subtract y from both sides. So x equals 2 and y equals 2. We know dx is 0.05 and we want to find dy. So the first thing I would say is we substitute 0.05 in for dx. Not necessarily. So let's group the dy over dx's and move this other stuff to the other side. So dy over dx. We're going to leave this over here and move this over and factor it out. So 1 minus x equals, we need to move this to the other side. So y minus 1. So dy over dx, we substitute in 2 for x, so 1 minus 2 is a negative 1, so we'll get negative dy over dx equals 2 minus 1 is 1, so negative dy equals 1 dx. We know dx is 0.05, so negative dy equals 0.05. So dy equals negative 0.05. All right, so that concludes our video over differentials.